Okay, so we're just going to recap from where the section we ended off on before, just in case that needed some extra discussion. Sometimes when you end off on something, by then people's attention has started to lag. So the final flow control construct we looked at yesterday was the for loop, and it actually comes in two varieties now. In modern C++, the traditional for loop, which is designed to generate numbers in, well, generate values in ranges in a sense. Typically, most commonly, you use it to access things by index, so a number that represents their position in something. And it comes in the following format. It's got for keyword, and then three statements that go inside the for, inside the parentheses. So the initial statement is typically where you will both create and initialize your loop control variable. The loop condition is where you will test whether your loop control variable has reached its final value, whatever that might be. And then an update statement where you will bring your loop control variable closer to its end condition. And you almost always do this in a situation where you kind of know in advance or can calculate in advance how many times you want to do something. Whereas you'd use a while loop where you can't really do that so easily, but you can easily test when you're done. So that's normally where you make the decision whether to use a for loop or a while loop. Do I know in advance how many times I need to do something? If you need to do something a fixed number of times, a for loop is typically what you want. Or if you can more easily answer the question, do I know when I'm done? Then you use a while loop. Although, as I said yesterday, the while loop is the fundamental loop. All other loops can be expressed in terms of while loops. And then, of course, the single statement that's shown there in the example could, of course, be a statement list in a block with a pair of braces. And it could indeed be another loop. You'll see very soon we'll start nesting for loops inside each other to work with two-dimensional data. So and those can be nested arbitrarily deeply if you want. So they are arbitrarily complex. So that single statement doesn't have to be one thing. It can be many. I've seen the sort of flow diagram for it. Basically, the difference between it and the while loop is it keeps on revisiting this middle condition, but it will always execute the update statement every loop, and it will initialize, it'll run the initial statement once, only at the beginning of the loop. So here's an example for printing the first 10 negative non-negative numbers, so starting at 0 up to 9. Very common in C++ and other programming languages to start at 0 and go up to your count -1, rather than to go from 1 up until the full count of something. And the reason for that is the addressing scheme used in C++ is what's known as well, it's not unit indexing. Unit indexing is where you start at 1. This is zero-based indexing, where you start at 0. And the reason for that we'll discuss in more detail when we look at fixed length arrays and even dynamic arrays, to exactly how they work under the hood. Makes sense then that starting at 0 is a better place to count rather than starting at 1. However, you can, of course, do a loop from 1 up until less than, in that case, or equal to 10. That would work perfectly well in that case, since you're not doing anything with the value except outputting it. So if that's what you wanted, that would work perfectly well as well. And then, as I said, very commonly in C++, we typically create our loop control variable in the initial statement rather than just work with it there. In the original C language, you were only allowed to create new variables at the beginning of a block. And so, as such, you couldn't create them there. It's very common to do that so far. Is it possible to go from a larger number to a smaller number? Yep, let's do that right now. Nothing wrong with some examples. Let's do those examples in the a VPL system, because I still see there are a lot of people who don't make use of the VPL system properly, and as such, they are missing out, I guess. Let me do it with, so the more examples of using it in here that I can show, the better. So log in. I'll just do it in the hello world area, because that's straightforward. I'm not going to use the evaluations, I'm just going to run it. So let's enlarge, let's do it from scratch, can zoom in a bit even. So if we go bring in the standard namespace, not the standard namespace, the input output stream library. Now bring in the standard namespace. Create our main function. Main function, if it's successful, always return 0. And then we want to have a for loop that counts down. So let's do exactly that. Let's count down from 10. So we will simply then initialize our loop control variable to be our first value. So int I equals 10. We're going to do that as long as I is greater than 0. And instead of incrementing it, we're going to decrement it. So I minus minus. Then we can see out I at that position, or at that point in the loop, and see where we get to. So if we run that, and you'll see we can now count downwards. You don't have to count down in multiples of one, in increments of 1. You could, of course, let's say, count down the even numbers, let's say. So minus equals 2 to go down in units of 2, for example. And there we go. So you can modify this as much as you need. The only goal is that it brings the value of the loop control variable closer to the terminal condition in the guard condition. And then I think, as a later slide mentions, technically you could have a degenerate for loop that has no conditions of any sort, which would technically be perfectly valid C++, but is equivalent to a while true loop. Okay, so you're not going to have an I to output there. So you're just going to repeat hello infinitely. And then off into infinity, hello, 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 hello. So it's exactly the same as going while true. Okay, so let's go back to our slides. Yeah, you can see these are just variants of what I did before. You obviously don't have to use the loop control variable in your code. You can use it to control how many times something happens, for example, and so on and so forth. A very important thing to note is, by default, it takes the next, all of these loops take in the next statement. So I equals 0, I less than 10, I plus plus. If I wanted to do multiple things, like output I and then say loop iteration completed, that will say that for each iteration of the loop. Which is what I wanted. But if I didn't put in those braces, it's still legal C++ code. It's just going to take the next single statement as being the thing to do. So this will only output this at the finally after the loop is finished, which might not be what you want. So my suggestion is, even if you've only got a single statement, just put in a pair of braces anyway. You can always then easily add more stuff to it if you want. And if you don't want, you're just wasting a little bit of vertical space. I don't think that's a big crime. So that's my recommendation for you. Much easier than having this kind of error, which is hard to see. Okay, let's see. Okay, this is an excellent question. Could it ever be necessary to use while true? Now, yes, a lot of things have a sort of infinite loop that carries on until you quit the program. So anything that runs in the background will have a sort of while true loop. So for example, Dropbox running there in the background, it exits when I tell it to exit, not when it's done, because it's never done. So anything that runs continuously in the background will have a while true loop as a sort of base message pump. This is an excellent question as well. So let's take a look at that right now. Oops, not there. I can go away. So that they are different. So let's have int a is equal to 1 and int b is equal to 1. So if I output a plus plus, what am I going to get? I'm going to get 1 as my answer. Why is that? Because where the plus plus is where the action happens in a sense. And where the identifier is the result you get back. So if I run this, I will get 1 as my answer. But the value of a has actually changed. So if I output it on the next line, you'll see that it goes up to 2 like we imagine it would. Right? But if I did, let's say with b, I did plus plus b, you'll see where the plus plus occurs is where the change happens, and where the identifier is the result you get back. So here the change happens first, then you get the result back. So you'll get 2 followed by 2. Let's just put in something to split this up. So you can see you get 2 immediately. So if you're doing a for loop like this, like we had, a sort of straight up regular for loop, okay, there I didn't put in the braces after saying it was a good idea, so let's live up to my word. We get the count that we saw earlier, right? And if I change that to plus plus I, what do you expect that we get? It's exactly the same. It doesn't matter because we're not using the returned value of that expression. We're only using the fact that it changes I. So whether we change I before or after this expression is finished doesn't matter because in the body of the loop it's already changed. So it doesn't matter most of the time. Some people love to write their for loops like that. I typically write it like that. It actually doesn't matter 99% of the time because you're not using the returned value. You're using it in the body of the loop. So use whichever you're happy with. It really doesn't matter. No, not quite. It's really just a design decision for the language. You can think of it like that if it makes it easier to remember how it occurs. So yeah, it isn't, but that's a good line of thought. And if it helps you remember how things work, then yes. And game loop. Sorry, reading ahead. So if that helps you remember, then that's a perfectly fine way of thinking about it. It isn't what happens, but the idea is basically right. So infinite loops are usually harmful. If you don't want them, then they're harmful. So most of the time you don't want them. Most loops aren't supposed to be infinite loops, and they're normally an infinite loop because you made a mistake, because you forgot to change the loop control variable like that, for example, right? Because I'm never incrementing I, so it never gets closer to 10. So most of the time it's a mistake. But a very good example, game loops are infinite loops. You'll have a while true loop and then update the game world and so on and so forth until you're eventually done. it really depends how it's being used. The kind of loop isn't really relevant in that sense. So it depends where you use the value. So the basic thing is to think, if I want the old value back, you put the pluses afterwards. If I want the new value back, you put the pluses in front. If I don't care about it right away, it doesn't matter because I'm only looking for the side effect of changing the contents of that variable. So yeah, that's that. Don't worry too much about that. All right. Yeah, so if I changed it to less than 9, then it would only go up to 8, from 0 up to 8, and then of course if I put less than or equal to there, it will then of course go back up to 9. So the most common kind of error with for loops, these traditional for loops, is what they call an off by 1 error. Let's say you were trying to index the contents of a string, right? Then and you forgot to do something like that. So let's do something like that. Let's have a string. So we want to loop through the string. So we go str hello, and we want to output the letters in the string. And we want to go to the length of the string. Very easy mistakes to make. This one should be fine. So hello. The very easy mistakes to make are to forget that you start at 0, not at 1. And of course I'll get hello, which is not what we want. So that's an off by 1 error. Or to do something like this is actually to go too far, because there is nothing after the O there. There is no value at length. The highest possible index is length minus 1. So this will cause a logical error at best, or maybe crash your program, depending on that. In this case, it didn't do anything. It just sort of output a non-principal character in that slot, which is lucky, but it's a very common kind of error. That, so be very careful. It's from 0 up to length minus 1. Okay, let's carry on. We did talk about the infinite for loop. Still perfectly legal. Okay, decrementing, we've just shown that. We've also shown that you can go up in increments of 2. You see they wrote it out in a much longer style in the textbook. They say I is equal to I plus 2, whereas we did I plus equals 2, but same effects either way. And then let's move on to a do while loop. So I noticed there was another question. Of the plus plus after length, there's no plus plus after length. That's part of the I plus plus. That's to move I further. The length itself stays as it is. You can't modify length. It's part of the string. It's not something you can change without changing the string. All right, so let's, oh yeah, we're doing do while loops. So do while loops are different to a normal while loop because they have to happen at least once. So very common use for a do while loop is to do a menuing system, because you always need to display a menuing system at least once. So I typically try and keep my logical conditions as simple as possible by storing them inside a named variable, a Boolean variable, which is then easy to remember what it means. So let's have the world's most boring menuing system, which is just to say option A, say hello. Option B, or often let's say option X, but that's all you can do. Then we make a selection. Store our value in a character. And then read into it. And then do stuff with it. So in this case, it's not even worth doing a switch statement because it's so short. So if ch choice is equal to a, let's also handle lowercase a's, ch choice is equal to, I'm sorry, uppercase a's. then cout hello, else if it's equal to x or x. And we can quit. How do we quit? We change the loop control variable to false, and otherwise valid choice. Okay, it's not a very exciting menuing system. Say hello. Hello. Why is that not looping back though? Oops. I've lost one. I can't hold the top of it. Let me zoom out. Okay, so I'm going to have to reload. Okay, why did that happen? Should have looped more than once. Interesting. Why is that happening? Oh, because I'm not initializing this to true. I'm silly. It does stop after the first run. And any variation thereof. Interesting thing to note, if you do your menuing systems like this, you can, of course, send through all the options you want in one go. And then when we're done, just now I can't see at the bottom, but X for quitting, closed, done. Okay, let's go back to the questions. Oh yeah, thank you, well done. That's absolutely was my error. Good debugging skills. So do while loop, you use it when you want to present the options at least once, but obviously it's just a flipped while loop where it does its test at the end. So you could, of course, change your logic in a normal while loop and get the same effect. So don't feel like you ever have to use a do while loop unless the mark sheet tells you to. And I can promise you the second semester test mark sheet and exam mark sheet won't require you to use any particular kinds of loops. So whatever you're comfortable with is fine by us. So there's just the flow diagram for it. Obviously, you could now convert that into UML if you wanted to. Oops. So there's just some examples of it, but I don't think we need to go too in depth there because they are quite straightforward. Yeah, so the strict term for it is that a while and a for loop are a pre-test loop because the test condition happens before the body of the loop, whereas a do while loop is a post-test loop because it does the initial test afterwards. So the number of times while and for can execute is 0 up to infinity, whereas a do while loop is 1 up to infinity. All right. So there's just some more examples. It's better if you work through those examples by coding them and seeing if the output matches your expectations, because the actual act of coding is what's important. The act of typing and making mistakes and fixing your mistakes is how you build the pathways in your brain that are useful for programming. So yeah, all of these loops have their place in C++. For loop, if you can figure out the number of times you need to do something in advance, you should use a for loop. If you don't know how many times you want to do something, but you know when you want to stop, then you use a while loop. And same situation, but you know it at least once, then a do while loop is appropriate. Okay, break and continue can be abused, but we will show you how to use them now. Let's just test it. It's up to you, but it is very useful. I do particularly like to use them for menuing systems. I'm quite fond of named flags, but other people would prefer to have a more complex expression. That's an individual style thing, and you should never be penalized as long as you're correct for it. So that's perfectly valid sentiment. All right, let's continue, and let's now take a look at what was I going to take a look at? Oh, break and continue. All right, so let's do something where we're going to find a value in a collection. The only collection we know about at the moment is a string. Should we change that, I wonder? Let's do it with a string first, and then we'll see. So let's say str, I don't know, sentence is equal to, it was a dark and stormy night. And let's say we wanted to search for a particular character and see if it occurs in the sentence or not, right? So we can easily do that with a for loop, for example, as we've just seen. I is equal to 0. I less than str sentence dot length and I plus plus. Let's say we were trying to be efficient. In Computer Science 1A, most of the time, don't really worry about being efficient, just worry about your thing being correct for now. But let's say you're searching to see whether or not a character is inside a particular string. So as soon as you found it, you can stop looking because you found it, it's there. Maybe there's more of them, that doesn't really matter, but it's at least there once. So what you can do is stop early in that case. So let's say that the character that we're looking for, caps lock. Okay, let's say we're searching for the lowercase d letter, which we know is there. And we want to stop looking once we found it. So basically what we want to do is we want to say if str sentence at position I is equal to the value we're looking for, then we will output a message that says that we found it. And then we want to stop, right? Now, if we were doing a while loop, we could modify the loop control variable. We could even JIPO, in this case, I, and make it greater than or equal to length so that the loop will stop automatically. But that's a very artificial way of stopping a loop. I mean, changing a flag is perfectly reasonable. People would understand that. But changing an index value that's being incremented to stop a loop, that's weird. That's going to definitely not be what people expect. So there's actually a special keyword for stopping a loop early, and that keyword is break. You've actually already seen it in the context of a switch statements to end that particular case in a switch statement. So its meaning is very similar here. So let's take a look. So let's first, so we can see each step. Let's say is take this out and put it into its own character. And then so is ch current equal to ch letter. Okay, and then we can see that it'll stop looking once it's actually found that D. So we'll see each comparison one at a time, unless I've made a mistake, which is always possible. So, and then it found it, is D equal to D, and then it stops. So the loop doesn't carry on after that point. So that's the purpose of the break keyword if you ever need it. Some people consider it to be bad style. They'd rather that you build the logic into your loop and your termination conditions rather than hiding special cases that will end it deeper in the code. Because the idea being, if something's very complicated and we want to know when will the loop end, we should know exactly where to look. And then for a for loop, it would be there. We don't have to have some hidden condition inside the code that will end it early. So people do consider breaks and continues to be something that can be abused. So before I discuss continue, let me just take a look at the questions. I can take a look at getLine if you want. It's easy peasy. Okay, it's length -1 if you start from 0 and go up to and equals. If you use less than or equals, then you need to say length -1. And if you don't say less than or equal to, then you can just say length. Either way will work. And we'll do the for each loop lengths, don't worry. That's on our list. Fair enough. I also don't like it, but what if there's more than one D? So in this case, our question was just to see, is the letter present or not? If you wanted to count the total number of Ds, for example, then you would always have to loop up to the end because the final letter could be a D. So there's no way to stop that one early. So in the context of this discussion of break, it's not a situation that we worry about. Okay, breakpoints when running a project. I'm actually not going to go into too much detail about that because I find that we might do it. Let's struggle a bit without using the built-in debugger and develop the sort of skills of reasoning about your program and maybe using output to see what's going on before we start looking at using breakpoints in the debugger. I find that a bit of a crutch sometimes that people over-rely on them. And in some situations, you might be programming on a computer, like on a small embedded device, or something where there isn't a debugger for you to use. So the skill of reasoning about your program and looking at outputs and figuring out where things go wrong is an important one to build. So we're not going to look at the debugger yet. It's a useful tool, but it's also something you can over-rely on. So it's a good question. You're definitely not wrong for asking it, but I'm not going to use the debugger much, if at all, in this semester. Rather build the skills for debugging by reasoning. Yeah, so break will stop the currently nested loop that it's in. So at the moment we haven't nested any loops, so it doesn't really matter. So it'll break the loop that it's currently in. All right, so that is good. Let's take a look. Okay, so continue. So what continue will do is it will stop, but it will then continue. Stop it, then continue. It won't stop the loop entirely. It will stop the current iteration of the loop, and then it will continue from the beginning of the loop. So let's drop this example, and let's just loop a fixed number of times. Okay, let's say we want to do 1 up to 10. And then let's say we wanted to count up to 8. But do we want to do that? Let's just think. So let's say if this number, if this number is odd, we're going to, or even, we're going to output it's even, but otherwise we're going to continue. So we're only going to do our, it's a bit dumb, we're only going to do our thing if the condition is met. So if I mod 2 is not equal to 0, then we're going to continue. Otherwise, at the end of the loop, we're going to say this, not this, let's just output the value. I was even. So when continue happens, the loop stops at that point. It doesn't reach this code, but then it restarts the loop from the next value. So it basically just revisits here, does the increment, and continues again. So if we run this, and you can see it does work. It outputs only even values and says that they were even. Of course, you're saying we could restructure this code and use the proper if statement and blah, 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 and not need to use this continue, and that's perfectly correct. You never have to use break and continue. There are options, and as I said, some people strongly dislike them because you shouldn't look in the, you have to go hunting for reasons that your loop stopped. So we show them to you because they're part of the language. I don't use them much in my style of programming. They're not wrong. Sometimes they're a really good option, but they can be overused. So that's the difference between break and continue. Break stops the loop forever, kills it dead. Continue just stops that current version iteration of the loop, but then resumes from the next one if there is a next one. Why would it stop in the first place? I'm not quite sure I understand your question. What would it stop in the first place? The loop. So if this was a break, right, the whole loop will stop dead the first time that triggers. nothing, no output, right? If it's a continue, as you can see, it only stops that iteration of the loop and then carries on. So that's the difference between those two. Yeah, but different people have different interests. So what I find interesting, you might not find interesting. So I like programming AI systems, so those interest me. I have programmed games, but only very simple ones. The actual mechanics of the game, it's not something I'm very good at designing. Fun game, for example. So if I ever were to write a game, it's either because we're teaching Computer Science 1 and we do games in the first semester, or because I need a test environment for some AI thing. So, but what's interesting to someone is not interesting to another. So it's difficult to answer that outright. So yes, I find the stuff interesting, but that's a value judgment. All right, so continue, blah, blah, blah. And then that's discusses the two. So yeah, you could, so you could do that. Let's do that with a for loop. So we're going to create a right angle triangle. Right. So every time we loop, we're going to loop again, because the statements inside here can be other for loops. So what we're going to do is every time we go forward, we're going to loop one extra time more and output more lines on this thing. So traditionally, the nesting for loops is given as follows. It's I and then J and so on. But you'll see that when we do two-dimensional data, I typically name the nesting R and C for row and column, but that's up to you. So what we're going to do now is we're going to compare J with I, and we're only going to loop as many times as I says. We're going to increment J, and we're going to output a single star, and then we're going to output an end of line at the end of that line. Let's see what we get there. And you can see we drew ourselves a terrible triangle. That's published, so you can look it up in the UJ library. So this is more useful for you when you hit honors, but if you want to look at published work, you do have access to some of the paywalled databases in the library. So if you go to the library and you go to databases, and then there are different databases for different things. In computer science, we typically publish in ACM, that's the digital library for the Association of Computer Machines, of Computing Machinery, and then Springer Verlag, we also publish in a lot, and sometimes the IEEE we publish in. So you'll be able to find them through the databases that we have there. Okay. All right, let's take a look at that. So we did nested loops, and obviously you can nest them as deeply as you need to. And we'll do a lot of nested loops this semester. And there we were. Likewise, you could invert it. Nothing terribly complicated about that. Then taking a look at avoiding bugs by avoiding patches. Let's not really worry too much about that. The debugging loop we've discussed a lot. You see, when I make a mistake, I look at my error, I go and fix it. I try and reason about why the values I see are different from the values I expect in my mental model. So computer science, a lot of people say, why is it called a science? It doesn't follow the scientific method. And that's completely untrue. They say maybe, oh, maths isn't a science because it doesn't follow the scientific method, and that's a different line of argument. But in computer science, which is a branch of maths, so I say you definitely can't say it's universally true for maths either, but we do follow the scientific method. The scientific method requires you to come up with a hypothesis and then collect data to try and invalidate that hypothesis. And if you do find data that invalidates your hypothesis, you refine the hypothesis and keep going in that loop. Debugging is the same thing. In your mind, you have a mental model about what your program should do. You run the program with some inputs. That's like running an experiment. then your mental model is either satisfied, the program does what you want, or something's wrong. It doesn't match your expectations. If it doesn't match your expectations, you need to revise your code, right, to match your mental model better, and then try again. So every time you do the debugging loop, you're applying the scientific method. You've got a hypothesis about what's wrong. You try and see if it's correct, and you either validate or invalidate the hypothesis, refine your hypothesis, repeat, on and on. And then, yeah, let's do the for each loop now. Great choice. So the for each loop has one specific purpose in life, and that purpose is to loop through collections one at a time, right? So the only collection you know about at the moment is the string. So let's just again go with str hello, just do what we did before. So instead of indexing the string, what we can do instead is we can say, I want each element in the collection one at a time. What kind of element is a string? It's a char. So we make a loop control variable of the type of the collection. And then we say, where do those elements come from? They come from this collection, str hello. And then inside your loop, C will take on the values of str hello one at a time. So it'll be H first, then E, then L, then L, then O, and you can do whatever you need to do with it. So in this case, we're just going to output it. And you'll see then that it works. So it's a much simpler way of accessing the elements in a collection. You don't have to worry about being off by one. Do you start at 0? Did you forget to do less than or equal to and -1, or just less than the length? It makes your life much easier. Very commonly, because in the future you'll work with all kinds of collections that aren't just strings, you can sometimes use the auto keyword, which we haven't seen before, which basically says let C++ work out what the type of C that C needs to be by looking at what type the collection is and assigning C appropriately. You don't have to do that. It's just a little neat, simple thing. We'll do exactly the same thing. And then I'm just going to stick with char here. Notice that this doesn't let you actually change the values inside the string. So if I said C is equal to something else, let's say X, right? And then afterwards, I want to output str hello. You will see that that doesn't work. str hello was unchanged. But like what we learned when we did in the tutorial, the reference parameters, you can actually make C a reference, character reference, and then it will be changeable. So if we run this now, you can see that we were able to change the contents of the string with the for each loop. All right, let's take a quick look at the questions. What notes? What notes? Are you talking about the lecture slides? They're under lecture notes. It's lecture 2. Yeah, on Eve. Okay, yeah, so auto is a type which will automatically work out what it needs to be. And then it's that type permanently. So when I said auto C, and C comes from string, it knows that a string is a collection of characters, so it knows that C must be a character. So it's called type inference. You do not have to use it. It's just a useful little thing. Oh, okay. I'll see if I can find that. You can, of course, just watch the tutorial and type the code. It's always useful to do that. And then let's just quickly look at the remainder of the slides, but I think we're basically done with anything that's important. And this is just a quick review. So we've basically finished everything that we need. Yeah. So the semester test is up to here. Nothing more than here. This is the end of it. Well, except for practical, the current practical that you've got you. So up to the stuff that's at the end of this week, that's where semester tests 1 is about. So I can answer a couple of questions. We can stop at about 6, but we're technically done now. All right, would auto work with arrays? Yes, it does, but not quite the way you think. There's 2 different kinds of arrays in C++. There's the built-in low-level array. That will get confused. And then there's the array data type from the standard collections library, and that will work fine. So yes, but be careful is the answer there. The recorded lectures are also available through Eve, so whichever one he was talking about, our correct answer is Eve. Can I show for each example something other than a string? We don't have anything other than a string at the moment to work with. So I could, but then I'd have to introduce you to an entirely new collection. There isn't enough time for that now, and it's not in the semester. Let's not confuse it now, but I promise you we will. Good question, though. How does how does the VPL handle running multiple instances? So yeah, basically each one of them gets run in what's called a jail, which is kind of like a very lightweight VM. So it's a little sandbox that prevents them from accessing stuff. The amount of resources that they have access to is limited, and they can only run for a certain amount of time before they're killed automatically. So it's kind of like a hypervisor. I think the exact mechanism depends on how you've set up the server. So it either runs in just an in-memory jail, or it uses a proper virtual machine setup. So it doesn't require a kernel driver, so I suspect this is all done in memory. So good question. The test is 40 minutes long, just like all the past papers from previous years. But you will have extra time to upload, so bear that in mind. So semester test 1 will cover up to what we've done today, but technically the stuff that's in Prac 3, that's due tomorrow. Well, not due tomorrow, it's due on Friday, but it is also in scope. So, but basically, yes. Okay. Yeah, you asked me, will we be tested on the Pracs? But there's literally a notice on Eve telling you what the scope is. So none of this is something you should be asking me, because you, as a student, should be reading notices. They're compulsory, and it's like literally even the first notice. There's nothing else to say. Are there practicals in the scope? Yes. Which ones? 1, 2, and 3, right there. The test is not practical, but we can ask you theory questions about code, which you have definitely 100% seen, because we've been doing that in the tutorials. Okay, when are we writing the semester test? Again, also, this is a huge sign that you are not participating correctly in the course. And if you keep up like that, you're going to fail, or we'll get you deregistered. So please shape up, right? So it's literally there. When is the test? Bam. It's also been in the learning guide since literally the first day of class, and we literally went through the learning guide in the orientation week. Yeah, but it's theory, but we can ask you code, which we have done. Look at the past papers. Yeah, so don't let other people will know a lot more. Don't worry about that. Just worry about understanding what's in the tutorials and the notes that you see. There's a whole bunch of other stuff that's very interesting to know about, but only the stuff that's mentioned here is in the scope for the test. So you just worry about getting the best mark you can in the test. Everything else will come over time. All right, so it's basically, some people have been running the race for longer, so they've gotten further. That doesn't mean that they're better athletes. It just means that they've been running for longer. You too will eventually get there. You just worry about, with any kind of race, take it one step at a time. All right, so I think that's that. I think we're done. So I wish you all a good evening. Please practice for the test. Watch the different tutorials. We do different past papers in the different tutorials. I'll put them all up on Eve. This list here will grow to include all the different video tutorials. I'll put the ones up from today as well. Oh yeah, the guy was asking me about code from the tutorial today. There was no code from the tutorial. We did past papers. The person didn't watch the tutorial. Okay, anyway, goodbye. Have a good